Hi, what is this?
So I want to see if you guys can do a challenge I'm actually showing.
Okay, sure.
So it has to do with this. So here I have a simple accelerometer, and the reason why it's a simple accelerometer is because this device detects acceleration.
Yeah.
So I have water, and there's a buoyant ball in there, a red plastic ball, right?
Yeah.
Regardless of the direction I accelerate, that buoyant object will get pushed in that same direction from being at rest. If I accelerate this way, the ball will get pushed this way. If I accelerate that way, the ball will get pushed that way, right? In any vector, it doesn't matter, right? The ball reacts to acceleration 100% of the time. So the challenge is, can you accelerate this, how it is, vertically, from being at rest to this line in 1 second without the reaction of the ball? Do you think that's possible?
And you can only move that.
Yeah, you have to accelerate this container to this line in 1 second without the ball moving.
It has to be still vertical?
Yeah, it has to be vertical.
Wow, that's upside down?
It has to be like in this orientation.
No extra gadgets or anything?
I mean, you could use anything you want, any force to accelerate this.
So the whole rule is we're only allowed to apply forces to it?
Yeah.
Okay.
In 1 second.
In 1 second to here. So a distance of 2 feet in 1 second.
Okay. Just put it out there.
Yeah, so just move.
Even a slight, it'll move.
Yeah.
Well, the reason it's moving forward is because the water's
Pushing back.
more dense than the ball itself.
Yeah, you
so
did
it's-
it. Yeah.
Engineer over here.
Oh, that's good. That's good. Do you think it's impossible?
I don't know about impossible, but I mean,
I don't think it's impossible. I think
technically. Okay. And
In 1 second.
in 1 second, and you're not allowed to, and you don't want it displacing in any direction, right?
I mean, yeah, basically. But I mean, if you accelerate it front, it's always going to go to the front. Like you can accelerate this and then it goes to the back. That's another impossibility in my opinion.
Yeah.
So the fact is, it is impossible.
it is.
Yes, it's impossible. So it's like me asking you to fly, or me asking you to walk on water. You can't break physics. So this will always react to a force. It will always react to acceleration. That's the point. So the reason I'm doing this is when I have this at rest right now, right, and I release it, do you guys believe gravity accelerated down towards the earth? Yeah. So here I did it in slow motion. I accelerated one down, and can you guys tell which one I actually accelerated down? The one on the left or the one on the right? Which one did I actually accelerate down? The matter within the container is going to show you which one's accelerated down. Because the more dense goes towards the back, and the less.
So that one.
Exactly. That's the one I actually accelerated, because as soon as I apply a force, the reorientation of matter happens. The more dense goes toward the top, and the less dense goes towards the bottom.
Yeah.
The one on the left here is free fall, which people claim is acceleration, but the fact is gravity is just a theory, and the reason why it's a theory is because a physical downwards acceleration has never been measured. So accelerometers don't detect acceleration in free fall.
It is accelerating. It's just that the water is accelerating at the same rate in free fall.
So that's what I was saying. That kind of acceleration that can accelerate without displacement doesn't exist. People that claim that happens in free fall, I would say that's special pleading. So that's why gravity is just a theory, because it can only be demonstrated in free fall, which is the observed phenomenon. The fact is the Earth is not pulling you towards the ground, it's the Earth pushing up against you. So gravity is not a pull, it's a push. And buoyancy shows us that, because like you said, buoyancy will always get pushed in the direction of acceleration. Again, I can demonstrate that here. If I was to cut the string, what direction would the ball move?
It would still move the same way.
No, if I cut the string right now, what direction will the ball move?
Up is buoyancy.
Exactly. Buoyancy, again, what is buoyancy, if I may ask?
So this ball is displacing a certain amount of volume in the water. The water is more dense than the actually.
Yeah, like you said right now. Yeah.
And so the ball gets pushed up by that force.
So again, so the water is pushing up the ping pong ball.
Yeah, so
I mean,
buoyancy is just gravity of the water pulling down.
But gravity is a push. That's my point. So right now the Earth is pushing up the table, the table's pushing up the bottle's pushing up the water, and the water's pushing up the bottle.
That's the normal force that just opposes the gravity.
You're talking about normal force.
Yeah.
They talk about the normal force because they have to, because buoyancy shows that there is an upwards force. But the fact is, this downwards force that they claim goes against buoyancy doesn't exist. Because if that force did exist in free fall, a vertical downwards acceleration, buoyant objects wouldn't go up. They'll go down too.
Is there like a reading?
But the only reason buoyancy exists is because there's a normal force that keeps the water like pressed up. So like if the water in this example in the free fall example stayed still, if it had a force like pushing it, like maintaining it, then it would still act the exact same way as that. The only reason it's in free fall is because all of those things together are
accelerating together, right?
Yeah.
That kind of force doesn't exist. That's my point. That kind of force cannot be recreated or demonstrated in any other vector, and that's why it's just a theory, and that's why it's just special pleading. For special circumstances that's happening in free fall.
Is there like a reading?
Like if I
I actually do have something I can share with you guys.
If I drop this, like what's that?
That's a deceleration from the constant.
No. Like when pretend I don't.
Yeah, right now everything's in motion already.
When it's in free fall, it's constantly accelerating.
It's decelerating. It's changing its rate and velocity. Yes, it's changing the rate and velocity, but it's decelerating. It's losing momentum. That's what's happening. The Earth is moving up to it. That's not moving down towards the Earth.
I don't buy that.
No, that's what physics shows. That's what physics shows. That's my point. That's why I'm out here. So let me ask you guys this. So everybody's cell phone has an accelerometer in it. That's why you could turn a landscape and portrait. It can detect the vertical force, right?
Yes, that's correct.
And you could download an acceleration app on your phone as well. And what that does is because on Earth we have 1G, right? When you accelerate that accelerometer on your phone, it registers 2, 3, 4G. Depending on how much force you apply, it registers plus G. Down, it doesn't matter what direction you accelerate. In free fall, however, it goes from 1G to 0. So it's a deceleration. Even cell phones show that. So a digital accelerometer or an analog accelerometer shows that there is no downward acceleration in free fall. And again, this is the biggest lie on Earth, and I'm going to tell you guys why. Do you guys believe the Earth is a ball? Right?
Yeah.
So if up is relative on a ball, right? If you're standing here, up is this. If you're standing here, up is this way. In other words, it's in every direction away from the center, up. And if we could prove that it's literally the ground moving up, pushing up against you and not pulling objects down, how can the Earth be moving up if it was a ball?
You're making an assumption that it moves up.
No. Hypothetically, if the Earth was moving up,
well, then that
it wouldn't work, right?
This proves that the Earth moves up.
No. So obviously you understand that the Earth moving up wouldn't work from a globe Earth model, which is why it's the number one lie on Earth that objects accelerate down in free fall, because that idea is what's keeping this whole globe Earth idea alive.
What if we just say it doesn't accelerate down, it accelerates towards the center mass of the Earth?
I mean, it's still an acceleration, and matter should react to that acceleration.
And matter should react to that acceleration.
Yes.
Oh, you're saying like why this doesn't detect free fall?
In cell phones too, accelerometers. Any accelerometer.
Yeah, I can explain that. So when it's just at a standstill, like everything is, even when you're standing still, like this is still experiencing a gravitational force, correct?
Well, I would say it's experiencing an upwards force. That's why the ball's moving up.
A force doesn't necessarily mean that it's going to be moving.
Well, if I cut the string, the ball will move. It's pushing up right now.
Sure, but like pretend even like this water ball, like forget the ball, like if it's just standing still, there is a force on it.
Yes, I agree. It's up a little bit, yeah.
There's one down and there's one up, and they balance each other perfectly, so that's why it's not moving. And then when it goes into free fall, that gravity force still remains, and that's why it's moving downwards. Like,
so you think it goes from rest to acceleration?
Yeah, and maybe the phone accelerometer it doesn't read that because it's calibrated for when it's at rest. So
the way accelerometers work inside your cell phone is there's a device in there that has rigid parts, and then it has some other parts that are loose. So it's like teeth that are coming together like this. So when you accelerate the phone, or those loose arms, they displace, they move relative to the direction of the acceleration, right?
Yeah.
So there's displacement inside your cell phone as well. So again, in free fall, we don't have that displacement because there's no force acting on it. Now, you're saying that the change in velocity that you experience in free fall, again, that can simply, if the Earth was moving up right now at a constant motion, everything was being pushed up. And obviously, because my hand is pushing it up, it's underneath it, right? As soon as I remove that, this no longer has that upwards force anymore. So it starts to lose momentum because of inertia. Inertia is the equal and opposite reaction.
No. It's
inertia.
It's not. There's no momentum when it's at rest. Would you agree?
There is. There's pressure. Would you agree that there's pressure right now inside this water right now?
Yeah, but there's no momentum. Momentum is just something moving that has mass into multiplied mass times force.
That's the thing. Everything is moving because the buoyant object is moving as well. You're saying the buoyant object is moving without anything else moving?
It's stationary right now, though.
No, but it's applying a force on the string right now.
Sure, but it's stationary.
You could say that visually it is stationary because everything is in motion together. But if we had a long tube right now and I cut that, is that?
If you cut it and it moves, then it's not stationary. But right now, it's
But
stationary.
my point is, if you believe we're stationary, right, and I had a long tube and I cut this, what's causing that bubble to go up if everything's stationary? I mean, the
buoyancy, gravity.
Even if it's not moving right now, there's still like a...
Yes, there's a force.
Sure.
Yes.
I don't disagree. There is a force, but there's no momentum.
Let me show you this. You guys know what a slinky is, right?
Yeah.
So I actually glued a ping pong ball to a slinky inside a water bottle, and guess what happened to the slinky? is stretched because of the buoyant force, right? When connected to
it
the
makes
earth.
sense.
Yeah.
I agree.
Guess what
There's-
happens in free
there's-
fall?
There is tension in the string.
When I put that,
But that doesn't necessitate there's movement.
there we go. So again, that ping pong ball is glued to the slinky when I'm holding it, and as soon as I release it, that upwards push is not there anymore. Buoyancy vanishes in free fall because it's no longer connected to the earth. So again, buoyancy is a motion transfer. It's a force transfer. Because force is motion.
I
Force
would
is
say
motion.
force, but not necessarily motion. There's no motion right here, but there's force.
You know, the second law of motion is F equals ma,
Correct.
which is force equals mass
Yeah.
times acceleration, which simply means matter in motion. So if you move your hand, that's a force.
Correct. But if you have opposing forces, then there does need to be acceleration.
But there is
Right
no
here?
opposing forces. That's the thing. How do you know there's a downwards force, if I may ask?
Well, I mean, the easiest way is like
Because I can.
you drop things, they fall, they accelerate. Like, how would you explain the fact that if you drop something and you measure its
Yeah,
velocity over time, it's
I
increasing?
100% agree that there is a change in velocity
Okay.
in free fall, but that change in velocity is a loss of momentum. It's a deceleration. It's
Okay,
not an
well,
acceleration.
Well, how would you define momentum?
Momentum is an object that's in motion.
That's velocity. How would you define like momentum?
Momentum is something that I guess is losing velocity, I guess. Is either, I mean, momentum, it depends what you mean. Increasing momentum will be acceleration.
Yeah.
Constant momentum will be constant. And a deceleration will be a loss in momentum. So it depends what you mean by momentum.
Typically, momentum is defined as just an object with mass that's moving at a certain velocity. So mass times velocity. That's the quantity
Something
of
that's
momentum.
moving, right?
And
Okay,
when
sure.
you apply a force to it, it loses momentum if you oppose. If you oppose.
Yeah,
that
I agree with
velocity
that,
vector.
100%.
Okay, cool, perfect. And if you apply it over time, so that time times force equals mass times velocity, which is momentum, your impulse is that like force that you're applying. It will be like it'll be canceling out your momentum fully. So it's like
Okay. Let me-
those things can be kind of thought as equivalent. It's like momentum is force over time.
Okay.
So you're applying something and you're accelerating it and you're giving it momentum.
Okay, just real quick. Obviously, we have a buoyant object here. If I had a steel ball in here, that's more dense than the water. What direction would the steel ball appear to
It'll
go?
fall down.
Right? So I can reorientate density and buoyancy. Like this, for example. What direction would you say I accelerated this vessel? To the left or to the right?
To the left.
Exactly. Because again, the buoyant object
Yeah.
moves in that direction. The steel ball didn't move towards the container. It's the container that moved to the steel ball. And what happened was that water wasn't dense enough to push the steel ball like it did the ball, so it only appeared to swing back. The steel ball only appeared to swing because the air's not dense enough to keep it moving, right? So when we release a helium balloon here on Earth and an apple, for example, the air is dense enough to push the helium up, but it's not dense enough to push the apple. So the apple, because of inertia, it starts to slow down.
Because gravity.
And then the Earth comes up. Well, it's inertia, it's not gravity.
wait, you
Gravity
said-
is a push.
Well, you said because of inertia, it's
It slows down, yeah, because matter wants to
down.
remain motionless.
Okay, so the apple, you're saying falls and then slows down.
It slows down. Yeah.
But then how do you explain that when you drop something, it's getting faster?
Well, because it's a loss of momentum. The more the object decelerates, the
Alright.
higher the difference in speed from the Earth and the falling object's going to be. So if you drop something from here, let's say the Earth is moving at 100 miles an hour, right? And we drop something from very low, it didn't have that much time to decelerate. So it probably only decelerated to like 95 miles an hour, right? So the difference in speed between the 100 and the 95 is only 5 miles an hour. The higher you drop something, the more time it has to lose momentum. So the higher the difference in speed between the constant and the free falling object is going to be. And that's why things appear to accelerate, because they're losing momentum. And the difference in speed between the Earth, it's increasing.
I feel
in the
like
free falling object.
the whole "are you smarter than this?"
I was gonna
test
say
is to
too.
determine whether like what you're saying is like complete nonsense, and if you can convince us that what you're saying is true, then we fail it. But
I was gonna say this is like a grade level question.
Well, displacement, understanding that the bubble or the buoyant object will always move in the direction of acceleration doesn't take a genius to understand that. This is an accelerometer. You can't break it. This is physics. You know,
I've
so
never taken a physics class.
well, this is, again, a 10-year-old can understand these principles. If you're claiming acceleration in free fall without any reaction of this buoyant object in free fall, and you claim accelerate, that defies physics. That claim defies physics, especially if you can't recreate that force in any other vector. So if you can show me gravity accelerating this vertically without that displacement, then I'll believe gravity exists. But that's the thing.
repeat that last part.
If you can accelerate this in any other vector other than free fall without the displacement of the ball in
Why
there,
would that be a requirement for gravity?
because that's the scientific method, measurable, testable, and repeatable.
Sure, but I mean,
It cannot be repeated. That's the thing. That kind of acceleration cannot be repeated.
Isn't me dropping this also like, okay, my hypothesis is that it's going to accelerate, downwards, it's gonna. So
Sure, that's what you visually interpret. Yeah, I agree.
Okay.
But if the Earth was moving up at a constant and that was decelerating, what would you expect to see?
Okay.
I mean, ask.
Here's a philosophical question. Sorry,
Sure,
I'm gonna ask one.
Sure.
Let's say there's a person. This is the Earth. There's a person here. There's a person here. How
Yes.
can they both drop apples at the same time?
Yes.
How can the Earth accelerate both upwards and downwards at the same time?
Well, the Earth is not a ball; it's a level plane. It's
I
literally
see.
moving up.
Okay, so we've moved to a flat Earth theory.
Well, it's not flat Earth. Flat Earth is bullshit too, and I'm gonna tell you why.
So, but it's still a flat like.
Well, over
a level
95% of flat earthers and all mainstream flat earth channels all claim the Earth is motionless. So what that means is they also believe in a downwards acceleration. So these are the controlled opposition. They're keeping a false dichotomy with the globe Earth because they're both claiming this downwards acceleration.
So what's your understanding
The
of like?
fact is that the Earth is literally pushing up against you, which wouldn't work from a globe Earth because that would mean the
So
globe
what is
Earth
the Earth?
will have to
what's
be
the Earth shape?
the Earth shape. The full dimensions of it is unknown, but it's a level plane. The surface that we live on,
It's a level plane.
it's a level topographical plane.
I see.
Yes.
Okay.
And it's a contained system too, because a lot of people would say, well, why don't you fall off the edge? Well, we have 14.7 psi here of air pressure, and in order to maintain air pressure, you require a solid barrier, a solid container. So the fact
Or
that
gravity.
we
Or gravity.
well, again,
won't
you
bring
have to
the air
believe
molecules
you have to
together.
believe in this downwards
Yeah,
flow.
I guess you do have to believe in gravity,
Yeah.
and you have to believe the Earth is round.
I would say the globe Earth is a religion because of that. You have to believe it. You know, nothing personal, but it's what it is.
Sounds good. Well,
But here's my channel. You guys can check it out. I go to other universities as well.
It's okay. Don't worry.
All right.
Personally, I believe the Earth is round.
Well, why do you believe that before you go?
So, because, well, first of all, if we talk about the fact that, well, do you believe the moon is round?
Yeah. I mean, it's a circle in the sky, sure. Yeah.
Well, then what about the fact that, like, when people went into space, and they looked down on Earth, oh, you don't believe people went into space?
Well, I assume it's being, yeah. I guess if you believe that, then I'm not
I
going to
would go to, like, the internet and look at, like, you know, videos of the moon landing, all of that.
I've been in this topic for 8 years looking for that, and I've only came across the motion of the Earth like the last 2 years because that's how suppressed it is, and that literally debunks gravity. And that's why all these motionless flat earthers are there to derail, to keep the idea alive of downwards acceleration, which doesn't exist. No, yeah, definitely, right?
thanks
All
for
right,
your
give you
time.
guys something to think about. All right, you take care. Hi, you want to give this a shot? Okay. Oh, it's her here. So, very easy. So the challenge I have, this is be considered a simple accelerometer, and the reason why is because this device detects acceleration. So I have water inside this container and a buoyant plastic ball in there, right? So it doesn't matter what direction I accelerate this, the ball will always get pushed in that same direction. I accelerate. You know, when it's at rest, the ball will always react, right? Always, 100% of the time. So the challenge is, can you guys accelerate it from here to this line in 1 second without the reaction of the ball? In other words, without the ball moving.
Oh.
If you guys can do that, then you guys win $100.
But you can pick it up and
You
stuff.
can pick it up too, but it has to stay vertically, and you have to accelerate it from here, but without the ball moving.
Oh, that girl, that's impossible. Physics.
No, it has to stay vertically. It has to stay vertically. The other way, yeah.
It's impossible.
Yeah, you got it. It is impossible.
It's impossible
Yeah, it is. Why do you think it's impossible? Because it is impossible.
because of physics.
Yeah, I mean, pretty much. It's like me asking you to walk on water.
So you
and
can't win the $100.
you can win the $100. That's a kind of a trick challenge, but here's the real reason why I'm doing this. When I'm holding this at rest right now, and I release it, do you guys believe it accelerated down towards the Earth by gravity? Yeah? So, again, when I actually did this in slow motion, just to prove a point, when I actually accelerated one of these down, and again, you see the reaction of the buoyant ball. Which one of these two would you say I actually accelerated? Down. The one on the left or the one on the right?
The one on the left.
You think this one accelerated down?
Well, you dropped it, right?
Yeah, but one I actually accelerated down physically.
Like you.
I grabbed it and accelerated down.
Oh.
Which one did I actually accelerate down?
No, one on the left.
You think this one's the one I accelerated?
Yeah, because why would, if that's buoyant, then why would it go down?
Because buoyancy always follows the direction of acceleration.
Yeah, but when you go like this, it's not going to go downwards because it's buoyant. So it's going to
Well, it's because when you're holding it like this, you have to actually accelerate it kind of fast because you're connected to the Earth. So what this proves,
Yeah, it can't go down.
well, But it could go down when I actually accelerate it down.
If you do like this.
Yeah, so the fact is, buoyancy shows you the direction the force is being applied because matter cannot move on its own.
Is this for class?
No, it's not for class. It's just pretty simple thing. So, but my point is,
Like, are we instructed?
Is this
So-
for YouTube?
it is for YouTube. So the point is, gravity is not pulling you to the ground. It's actually pushing up against you.
And there's no money prize.
It's just knowledge.
So it's just a
Knowledge.
scam.
Not really.
It's kind of a scam.
It's a real.
False advertising.
So point being, gravity
You
is
get knowledge through false
gravity is not a
advertising.
pull. It's a push, and we've been lied to about this idea of object accelerating down towards there.
What?
Wait, what does that have to do?
Wait, what is?
Yeah. So this is an accelerometer. It always detects acceleration, but in free fall it doesn't.
Wait, what is your
Wait, who's
like? What is
lying?
this thing?
Yeah.
So you
What
guys
is this
believe in a
for?
pulling force of gravity, right?
Yeah, of course.
Yeah.
Yeah. So the fact is, it's not the Earth pulling you down; it's the Earth pushing up against you. So the reason why you're stuck to the Earth is because the Earth is pushing up against you. You're not being pulled down towards you. That's the fact of the matter. That's why I'm out here. Yeah. So the Earth is literally moving up through space like this, and we're all standing on it. So you guys believe the Earth is
What
a
do you
ball,
mean?
right?
Wait, like.
Oh, you're flat earther.
Not a flat earther, but I also don't accept the ball Earth.
So what do you think it is?
The
Like
Earth is a level plane because it's in motion.
so it's flat.
Well, it's not flat because flat has no orientation. Flat is just a.
Constantly accelerating up.
It's not accelerating. It's a constant motion.
I
Because if
do
it was
not-
accelerating, your weight would be increasing.
No,
Why do you keep shaking that, if I may ask?
Because it's fun, and you don't
Okay.
have. This is like a. I don't believe that the Earth is not a ball. I don't believe that it's a flat plane.
Do you believe it's a ball?
Of course.
So if the Earth was literally moving up,
Have you ever watched like the Jubilee videos of like flat earthers versus like?
yeah, that's
What do
a
you
false.
think of those?
That's a false dichotomy because over 95% of flat earthers, in my opinion, mainstream flat earthers all claim the Earth is motionless. So they believe in a downward acceleration too, just like gravity. So they're keeping the whole idea of gravity alive, which is keeping the whole globe Earth idea alive. That's why it's a false dichotomy. So that's the fact.
What made you think that like the Earth isn't that?
Well, it's not a thought. It's practical physics, like you said. Buoyancy cannot exist without a force.
Yeah, but
Buoyancy cannot exist without a force.
gravitational
Definitely.
pull is a force.
Well, I don't know if you knew Einstein's theory of relativity. He claims that gravity is not a force. So he claims it's a force. It's not a force, but it acts like a force. So he double speaks. So it's all bullshit, pretty much. All these theories of gravity. That's why they're
Oh
theories.
yeah, everything's a
believe it?
theory.
No, is wood is steel stronger than wood?
And it depends on. It depends
Can you
on the
breathe water?
property.
What does that have to
Does
do
fire
with that?
burn? Those are all facts. They're not
But those
theories.
Those are different things.
Those are
though.
facts about our physical reality. Fire burns. That's not a theory.
But
That's a fact.
what does that have to do with breathing water?
The fact is that you can't breathe water, you'll drown. That's also a fact. That's not a theory.
But those things are so unrelated.
No, I'm talking about, she's trying to say that nothing can be proven, that everything's a theory. I'm trying to
She
say
didn't
that.
say nothing can be proven.
She said that everything's a theory. You did say that. Or do you take that back?
No, I didn't.
Okay, yeah.
We didn't say everything.
So physics,
We didn't say everything.
physics,
We said 'cause it's a theory.
physics proves things, basically. Understanding how physics works.
Are you vegan?
Oh yeah, I'm vegan. Yeah, I don't eat animals.
That's good.
Yeah. I think torturing animals is.
I'm vegetarian.
I would say that's no
Almost
different than eating.
I'm allergic to cashews, so
Oh, okay, I see.
yeah, a lot of vegan foods have cashews.
I see.
Do you go here
Oh no. I
to
don't.
the school?
No, I don't. I just challenge the current narrative. Because this is the biggest lie on earth. I know you guys might think it's funny, but the fact that there is no physical downward
I didn't laugh.
acceleration, for whatever reason, this is the biggest lie on
I
earth.
just said it's a scam.
Well, it's not a scam.
It
Well,
is a scam. It is a scam.
Well, it's a
The
scam that
definition
you
of a
believe
scam.
objects accelerate down in free fall.
It's a scam that you said if you're smarter than a fifth grader, promise $100.
But I didn't promise $100.
On your sign, it says if you're smarter than a fifth grader, you could get $100.
Are you smarter than a grader?
Fifth-
It says $100 challenge here. I don't know if you missed that part.
It's a challenge.
It's a $100 challenge. Yes,
So
you,
it did the challenge technically.
yeah, and you
I'm
failed.
smarter than a fifth
You had to
grader.
accelerate
I never
it.
failed. Right? We
The
never
challenge
failed.
was accelerating this without
But
displacement.
you said it's not possible.
It's not.
So it's not really a challenge. It's just something that's not
It's just something
possible.
just to start a conversation. Sure,
So
you
you're
could say
just
that.
starting a conversation. So what's the challenge?
The challenge is that gravity doesn't exist as a pulling force that can accelerate all matter simultaneously.
But if they challenge, there's usually a way to win, right? Otherwise, it's not a fair challenge. It's not
Sure,
a test.
well, you win knowledge.
So
That's my
what's
point.
What's your actual test?
Yeah, knowledge.
There is no test.
The test is knowledge.
So if I've gained this knowledge, right? So I won the challenge, right? Because I heard
No, you didn't win the
I won
challenge.
the
You
challenge.
won the knowledge. You failed the challenge, but you won the knowledge.
The challenge was to receive the knowledge.
No,
so
the
I
challenge.
received the knowledge.
No.
So therefore I get the $100.
No, the challenge was to accelerate this without displacing.
That wasn't the challenge because it's impossible.
Exactly.
So you said a challenge is something where you receive the knowledge, right? So that's the challenge. So if those are the parameters of what the challenge is, I did the challenge.
You did it, but you failed
I did it. I
The
didn't
fact
fail
is-
it, and you didn't say win the challenge. You just said $100 for doing the
challenge.
challenge.
Yeah, I explained the challenge.
$100, do the challenge, did the challenge.
I explained
I
the
get
challenge
$100.
before you started, though. If you can accelerate this to here, and I said, if you could do that, then you win the $100.
But you said that.
Can you guys accelerate it from here to this line in 1 second without the reaction of the ball? In other words, without the ball moving.
Oh,
If you guys can do that, then you guys win $100. I can't fit all that. I mean, I could fit it, but it won't
And you
be
never
easy.
said
Right?
win the challenge.
I mean, that's what a challenge is.
Well, if we're talking about winning, then if you're saying a challenge is something that can be won,
Well, that's what
this
I did.
can't be won.
That's what I asked in the beginning, though. If you can accelerate
so
this, then
this
you
is
win.
a scam.
Okay, sure. It's a scam. Sure. Yeah, it's a scam.
I'm just saying, if we're going off technicalities.
Sure, it's a scam. But you've been scammed as well about believing in the baller. That's the biggest scam
I'm not
on
too
earth.
bothered about it.
Oh,
Does
it's
it
fine.
really feel like it bothers you? Like if the world was a circle, would you feel like your life?
If you
would
were
change?
being lied to about your entire existence and the nature of the earth, and your existence within
But
the
it
earth,
doesn't change my life.
well, it does.
How?
Because we're living a fake life right now of monopoly. It's all made up. Money doesn't even have value. I don't know if you knew that. But people
don't
believe.
believe
It's a
that.
social contract.
Exactly. And why do people agree to a $50 trillion debt currency? Why do people agree?
Because
They just
the
believe what they're
system
told.
that was
Exactly. Because people are just too ignorant to
Yeah,
the
but
facts, and
that's-
people just do what they're told. People are too dumbed down nowadays because they believe Earth is a ball. Comes down to that.
But I don't think like money has to do with the earth being a. with
Well,
a
it just
ball.
shows. It just shows people that believe in the globe Earth, in my opinion, just shows that you're willing to believe authority over your own common sense. And if you're willing to do that, then you're going to be easily controlled about other topics as well. So it's a cheap shot on our common sense. It's not necessarily.
Honestly,
Yeah.
the earth being a ball, being a flat, doesn't it
What
doesn't affect.
benefit would authority have?
Well, I mean, if they could get a bunch of people to do everything that they're told, I mean, what benefit? I mean, they're literally controlling people, and people just believe
What
everything
does it
they're
have
told.
to do with the earth being a ball? Are you
Well, like
saying
I
it's
said, it's a cheap shot on our common sense when we're very young to basically give away our authority to in favor of our common sense. That's what it's about. It's a cheap shot on our common sense.
I don't think believing one thing means you believe other things. I can drink water. Well, it was lovely to meet you.
It's always good to start a conversation.
I enjoy conversation.
I go to universities all over the place, so you guys check it out. You guys want to take it?
It's okay.
I'm good, thank you.
You guys want to see yourselves?
I can see myself. I'm an actor.
Good for you.
Thank you.
Just like the astronauts. You might be a good astronaut if you actually went in that field. If you're an actor,
I don't think they'd let me in space.
I mean, if you're a good actor, I think you'll be a good
I have
astronaut.
to kind of study different things. But I would love to go to space. Why not? Oh, you know that dog? I want to be like. What if this is all a simulation?
It's not.
How do you know? How can you prove it?
Because a simulation would indicate that the laws of physics don't exist.
See, my character, the person controlling me, took my
A
job.
simulation would indicate that the laws of physics don't exist, but the laws of physics do exist. So a dream could be a simulation, but in a dream you can fly,
My
you
dreams
can
are
dream.
so real.
This is as real as it's gonna get. This is it.
Right on.
All right.
Right on.
Stay
Take
vegan.
care.
I like that.
Yeah,
Yeah.
stay vegan.
Oh my God! Like she was shaking it so hard that it untied from the base. So I'm gonna go ahead and call it now.
Well, no. Bro, call my brother. He's a physics major.
Okay.
Can he have a shot at this?
Is he coming?
He's gonna be here in like literally 2 minutes.
These two girls just messed up my accelerometer. They were just shaking it pretty
Oh.
drastically, so I'm gonna have to redo it, but not today. But
Oh,
but I guess we can still have the
could you
conversation.
do like a more theoretical? You make your point that he's
Sure.
Yeah, he's like right here.
So Wait, is he on the phone or is that him?
No, this is my brother.
Oh, is this your brother? Okay.
We're not related.
Brent, we look like
I always like walk around and I see this.
Oh, really?
You gotta hurry up. I'm not
Okay, because
He's like 1 minute away.
1 minute
I
away.
just want to understand like the point.
Well, I'm doing a $100 challenge, but the conversation I had before, they were kind of shaking this pretty crazy, so it kind of messed up my setup here. But basically, what I'm gonna show, I'll just show you this.
And a fifth grader could figure this out.
Yeah, it's just very simple physics. So when you have a buoyant object in a container like this with water, that's considered an accelerometer. And the reason why it's considered an accelerometer is because it detects acceleration. So regardless of what direction I accelerate this bottle, the ball will always get pushed in that direction I accelerate 100% of the time. That's physics, that's fact. You cannot accelerate this without that motion of the ball being pushed in that direction, right? So let me show you this, because I want you to understand. Here, look.
Have you talked to this guy before?
Yeah, he talked to me already.
Just listen.
Yeah, so since we understand that the buoyant object, in this case it's the ping pong ball, always gets pushed in the direction of acceleration, what direction would you say I accelerated this container? To the left or to the right?
Well, based on what I just saw there, if it goes to the right, then you accelerate it to the left. Right? No, why not?
Because the buoyant object, because it's less dense than water, when I push the bottle, the bottle pushes the water.
This is the ping pong, right?
This is the ping pong ball. So when I accelerate this to this direction, for example, the bottle pushes on the water, which creates a pressure gradient, and the water, because it's more dense than the ping pong ball here, it's able to push it in that same direction. Something that's more dense than the water will not be able to get pushed by the water, so it will only appear to swing back. So in this case, I accelerated this container to the right, because we could see the ping pong ball react to that motion, to that acceleration, right? The more dense object didn't move in that direction because the water wasn't dense enough to push it. So the container made contact with the ball, the steel ball. The steel ball didn't make contact with the container. Does that make sense? So one force created the separation of matter, in other words, density and buoyancy, right? So point being is, the buoyant object will always get pushed in the direction I accelerate 100% of the time, right? So when I actually accelerate this down, like actually accelerate it down, we actually get that reaction of matter. The buoyant object gets pushed down in the direction of acceleration. Which one of these two would you say I actually accelerated down? The one on the left or the one on the right?
And what you're arguing now is that the one on the right.
Yes, that's the one I actually accelerated down, because we see the reaction of the acceleration. The one on the left, however, is so-called free fall, which people claim is acceleration. The fact is that if it was acceleration in free fall, matter will react to that acceleration, because that's what accelerometers do. And when you have solids, liquids, and gas in a container, they will always reorientate relative to the direction of the force. So, in other words, people are claiming or believing that when you release an object into free fall, that Earth pulls it down towards the Earth, but the fact is it's the Earth pushing up against you. So you're not being pulled down towards the Earth. So yeah.
Okay. Let him handle this.
All right. So you're describing something that led Einstein to go into
Theory of relativity?
yeah, the equivalence principle, right?
Yes.
Yeah, okay. So there is no difference on a small scale between the Earth accelerating up and us falling towards the Earth. But I guess two questions for you. With your, I haven't heard your full like theory.
Demonstration, sure.
Yeah, your explanation. How does it explain why light falls under the influence of gravity?
You know, well, light's not even a mass.
Exactly.
So I don't even know. So I don't think light is affected by forces, in my opinion.
It's not affected by forces, but it falls under the influence of gravity, right?
Well, I would say that's just theoretical. That's what we're told happens in space with light bending and stuff like that. What are you talking about?
It's measurable, right?
Okay, sure.
So there's been experiments done to demonstrate that, similar to your explanation with the Earth accelerating upward.
Well, it's not accelerating, but it's a constant motion. But sure, I get
What do you mean it's not accelerating?
It's not accelerating. So a lot of people think the Earth has to be accelerating because, but the fact is, matter has inertia. So everything has inertia, right? Matter wants to remain at rest. An object at rest will remain at rest unless there's an external force acting on it, right? That's the first law of motion. So that which contradicts
Newton's law of motion, which is from the 1600s.
But it's a law that's applied today. That's my point.
On Earth, maybe for kinematics, but not on celestial bodies.
So we have to go into imagination land. That's what you're saying now. But because here on Earth we can't demonstrate.
Well, here on Earth we can, right? Because Einstein's theory actually predicts, like, light curving around planets in a way that Newton's gravity doesn't, right?
Sure, but that's him claiming that gravity is a flow of space-time, which is what he claims, down towards the center of the Earth. When this flow that he claims is there, first of all, cannot be physically measured, because
yes, it can actually.
How did they measure it?
How do they measure the flow?
Downwards flow.
Well, that's what we experience as gravity. But if you want to, we know that gravity, we can measure how gravity is just space-time being distorted because of things like gravitational waves. Do you know what gravitational?
I've heard of gravitational waves.
Right,
I would say they're just theoretical, but
no, we've measured them, right?
How did you measure them?
So there's these facilities, right? And basically they have laser beams, right? And when you line up laser beams, right, so that their wavelengths are perfectly aligned, right, you can either have constructive or destructive interference, right? Which means that if they're aligned in a way so that one peak is at another wavelength valley, right, like this, the two lasers will cancel out, right? And so no light is formed. Whereas if you perfectly align their wavelengths, then the amplitude will be twice as high, right? Because the peaks are adding, right, versus subtracting. So basically what happens is we measure these gravitational waves by getting two laser beams pointed at each other from like miles and miles and miles apart. And basically we can measure the stretch and pull of these gravitational waves as the two laser beams are actually physically being pulled apart. We can see that they oscillate between constructive and destructive interference.
So that proves to you that there's a flow accelerating objects down towards the Earth.
No, it's what is called gravitational waves.
So that proves to you, that explanation you just gave to me, proves to you that when I release this object, it accelerates down towards the Earth. Right?
No, it proves to you that you can measure gravitational waves. That was your initial question. You have to let him.
Well, let me be more specific. How did you measure a downwards flow of gravity?
Well, I measured downwards flow of gravity.
Downwards flow of gravity that makes this object go to the ground.
What? 9.8 meters per second squared.
So I wanted you to get there. So you're measuring a change in velocity. That's what you're measuring, right?
That's acceleration, right?
Yeah, it could also be deceleration. I don't know if you knew, you could look that up. A change in velocity can also be deceleration. So what you're measuring is a change in velocity, but it's a deceleration. So if the Earth is moving...
It's not.
So, okay, say
if
right
I
now...
drop an object right now, it accelerates to the Earth.
No. So if we're moving up at a... I agree with that. So if we are moving up at a constant right now, 100 miles an hour, we'll say, theoretically.
You wouldn't feel anything.
You wouldn't feel a pressure under your feet?
No.
Why not?
Because how come when you're in a car with the roof closed, right, going on the highway 100 miles an hour, you feel it's an inertial frame, right? You can't really prove that you're in a car driving 100 miles an hour unless you see that object.
You want to know why you can't prove that at a constant rate? Because you're connected to the Earth. You're already experiencing a constant force.
No,
in order to
you just said constant force, which is different than a constant velocity, right? So a velocity is not an acceleration.
Yeah.
An acceleration is a change in velocity, like you said. That was your definition,
or deceleration.
So if you're saying that Earth is moving at a constant speed, then we would move at a constant speed, and then what happens when you jump?
You have inertia.
What do you mean you have? So based on your definition, right? It's moving at 100 miles an hour, like you said.
We don't live in a frictionless environment.
Okay.
You think matter just moves infinitely by itself, right?
I'm gonna deal with your
Sure. I know where you're going, but go for it.
It's moving 100 miles an hour, right?
Sure, hypothetically.
We're moving. That's what you said.
Okay.
But we're moving with it.
Yes.
Also at 100 miles an hour.
Yes.
So then, if we jump up 2 miles an hour, wouldn't we be now going 102 miles an hour and then just flow out?
No. As soon as your body, that force is no longer there, as soon as you jump up, you did accelerate up.
Well, you were using Newton's laws, right? And so
I'm just using practical reality.
If Earth is accelerating us at a certain point, we start moving with the Earth completely. Why? How come when we jump up, we suddenly aren't moving with the same speed?
Because you automatically, once that force underneath your feet is no longer there, you start to decelerate, lose momentum.
You're using like your visual world. If I push an object, once I move my hand, right? It's not like the object just stops. It keeps following.
Yeah, it has to decelerate. So if you're going 100 miles an hour and you let go of the gas, it's not going to completely stop to 0 miles an hour. It needs to decelerate. You need time to decelerate. It goes from 100 to 99 to 98 to 97 to 96.
Well, the reason the car decelerates is because of friction.
Yeah. Inertia is friction, but it's not air. It's the background medium that people claim is gravity.
Well, I don't.
That's just inertia.
Even so, even if I guess what you're arguing is that, right? So we leave the Earth and the air, right, is what slows us down.
No. Air slows you down as well when you're moving horizontally, but when you're moving vertically, again, matter has inertia, meaning it resists motion. So matter wanting to resist motion is what makes objects appear to go down, because once that force is no longer pushing up on the object, it starts to lose momentum because of inertia. So matter has a resistance to motion.
What underlying principle do you have to justify inertia? Is inertia the basic principle?
Yeah, the fact that there's no displacement in free fall, because if people claim acceleration in free fall, there should be displacement, but the fact that there isn't shows that there's a deceleration.
What do you mean there is no displacement?
So when I accelerate a container with a solid, a liquid, and a gas, like I don't know if you've seen it.
He's saying the ball doesn't move in free fall, whereas if there's acceleration, it would be pushed down.
Yeah, look, when I
But
accelerate,
when it jolts it down, it pushes down. So you
yeah,
gotta
look,
watch
when
this
I
demonstration.
accelerate, again, I'll show this again.
Yeah.
There's a reorientation of matter. The line, this vertical line of the string, shows the vector, right? The vertical vector of gravity, right? But I'm saying the vertical vector is not down, it's up. My point is, when I apply a force, I can change the vector.
Well, okay.
When you accelerate
This
down,
experiment is independent of gravity.
Well, it's a force. This is force.
That demonstrates buoyancy.
What is gravity? Let me
and-
ask you, what is gravity?
Let him finish his point.
yeah.
He's making a great point.
That demonstrates buoyancy and density, right? Density is independent of gravity. It's mass, right?
Well, with density, sure, it's mass. But the motion of density, what creates that?
You mean the motion of density?
Yeah, the apparent...
Density is an intrinsic property of matter.
Yeah.
It doesn't.
Yes.
It's not created. I mean,
So you're saying gravity pulls this to the ground and then pushes a helium balloon up? So gravity is acting in two
no.
vectors?
Gravity pulls a helium balloon down in the same way that it pulls that water bottle down. But the reason that a helium balloon will float, whereas that falls down, is because the buoyant force inside of the helium balloon outweighs the force of gravity, right? So there is a force of gravity pulling the balloon down, just like it pulls that bottle down. But since the density of helium is so little, right, the buoyant force created outweighs that downward pull.
Bingo.
I agree. So buoyancy, and I can recreate this, I'll show you right now with a helium balloon.
Okay.
Buoyancy is an effect of a container that's in motion, and the reason why we have a buoyant effect is because the air is more dense and pushes it in that direction. But the air also
Watch
has...
this.
No, can I finish as well?
Sure.
So the density of the air being more dense than the buoyant object will push the helium in that direction, but the air also has to be moving in that same direction.
Yeah,
Watch this. So can I ask you something?
Sure.
When you drop this container, and your baseline of relativity is the container itself, does the container accelerate at 9.8 meters per second?
No,
Absolutely.
there's a deceleration of 9.8 meters per second.
So it's the same thing, right?
Well, it's a deceleration, not an acceleration.
It's the exact same thing.
Well, it's not the same thing because your theory. No, I'm going to tell you how it's different. Because you guys believe the object moved down towards the ground. I'm saying that it's the ground that moved up to the object.
Okay,
It's the complete opposite.
So wait.
It's not the same.
The Earth is a. Do you think the Earth is a sphere? Or do you think it's
No.
Okay.
So that's my point. So here, look.
Okay.
Yeah.
So we're getting
somewhere. Yeah. So
I knew
look,
it, bro.
I recreated buoyancy right here in a cargo van. So I changed
real quick. How do you then explain gravity on the moon where there is no air?
Now we're talking about imagination reference frames.
No.
Imaginary reference frames.
You are. Remember. At this point, at this point, we need to deconstruct your worldview. Are you an empiricist?
I'm a realist. I
You're
go
a
with
realist.
what I can prove things here on Earth.
What's it if he just actually pointed
No,
out?
let me just make this point real quick.
Okay,
and then
I'll
we'll
let
go
you
to the
make
next
this point.
because we're talking about buoyancy.
Then we'll break down the theoretical framework of your theory.
So buoyancy here, I can
got this.
prove in any direction when we have a container and a helium balloon inside that container. When I accelerate a container, the air, the motion of the van creates a pressure gradient with the air because the air wants to remain in its position because of inertia. But the van, because it's moving, it's pushing the air in that same direction. Now the air, because it's also moving, it has pressure because that's a push, can push anything that's less dense in that same direction. That's what buoyancy is. So when you
Could
release...
you define pressure and could you define gradient?
Yeah, pressure is a pressure gradient is simply a container that's in motion.
No. Just define the
A pressure gradient. So
just pressure and then gradient.
Well, pressure again is you require a container,
No.
and then you require a
pressure-
force.
There is a definition of pressure that I don't think.
What's
you
your
find.
definition of pressure?
It's a force per unit area.
Sure. What's force?
Mass times acceleration.
What does that mean?
Okay, so mass is a property of matter,
Yes.
right? And acceleration is
It's
the
motion.
change of velocity. Yeah.
Right. So force equals mass times acceleration. We simply mean something that's in motion, right? Something that's moving, right?
It doesn't have to be moving.
Well, it's not a force.
Well, if there's
That
equal,
goes.
if there's equal forces acting on a
If
single
F
object,
equals
then-
ma, how can that force not be moving?
Well, the force would move in the absence of another force. There can be multiple forces acting on an
Yeah, but
object
all
at
those
one
forces
time.
have to be in motion to be considered a force.
Sure, but the object itself isn't in motion.
I'm exerting
Yeah.
exerting a force on him.
Yeah, but
Not-
his
not-
resistance is greater than the motion you're applying.
It's equal. It's my leg. My leg is pushing
Your
off.
hand. Where's
There's
your
no motion.
Okay, when you're
I am
applying
pushing
the
off the ground. I'm like a cantilever.
when you're pushing when you're pushing something like this,
Let's get
is your
into
hand
that
moving in this
framework.
direction, this direction, this direction, or in that direction?
Wait.
You're applying a pressure, even if you're not moving it. What direction is the force being applied?
Let me abstract.
In that direction, right?
Can we abstract this really quickly?
Sure.
Would you be okay abstracting?
Sure.
Okay. Can I ask you what the basis of your worldview is? You say realism. Can you explain to me what that means?
My basis is what practical physics has to show me. That's what I go with.
So you're an empiricist in this way. You observe things, and if it is physically observable, to
If
your
measurable,
own eyes,
testable, and repeatable, it has to go through the scientific
can it be
method.
measurable by like very technical and precise instruments?
When people talk about measurements just by looking at something, that's not a physical measurement.
Okay,
if you're just
right.
looking at something and coming up with calculations based on what you're just seeing, that's not a real physical measurement.
Wait. So
It has
what's
to
a
be
real physical measurement?
So
You
a
said-
physical measurement will be having a substance like this and actually seeing the reaction of it and
you
measuring
just said
it.
seeing it doesn't prove.
Well,
that
I'm not
it's
just seeing it.
real.
I'm able to touch it. I'm able to manipulate it. I'm able to change the vector.
So you're saying
I'm able to
things
do all
that
that.
are only tangible to your own hands
Yes.
and your own
And everything-
immediate experience
Yes.
are what define and inform your worldview?
Yes.
You realize how impractical and antiquated that is.
I say that's the most practical. That's
Well, so in this idea, you would agree with, I guess, the earlier physicists like Aristotle, and you would agree that everything that I can see informs my worldview, and anything that I can't see is some immaterial, intangible object that just
yeah,
doesn't
that's the
exist.
difference between objective and subjective.
It's
Yes.
actually not, because you are actually describing a purely subjective experience. Because
I'm actually surprised.
No, you're not.
I'm objective.
You're- actually, I will explain to you what is objective and what is subjective.
Please.
Objective is what exists independent of our viewership and understanding of it.
Sure.
So, if let's say
So
that
like this accelerometer,
okay, no,
sure.
But let's say that I see this and I'm just like, it doesn't move. What are you talking about? I don't see that move. What is there an objective reality
If I
underlying
had
both of our
if
experiences?
this was a long tube and I cut
No,
the
but
string,
wait, dude,
there will be motion.
I don't see that ping pong ball move at all when you move it. I'm saying I don't see that.
What do you mean?
I don't see it. So it doesn't.
So when
move.
I'm moving like this, how do you not? I would say
I
you're.
don't know. I don't see it.
I would say you're a reality denier now.
No. Because you just said subjective is
Would
what-
you say? Would you
No,
agree
no,
with
no,
him
no,
that
no,
you
no,
don't see him
no,
moving?
Let me get my point. Let me get my point.
Sure.
You just said that what is objective is what I see, and I'm telling you,
What
I don't
I
see
can
that
measure, not just see, measure.
I can't measure a move. So, but my point is there can be this disconnect between what we observe and what is actually real. And you're saying reality is what you observe. You only
Well,
observe.
not just observe, physically test as well and manipulate.
The exact same thing, actually.
No, it's
the
not.
exact same thing.
No, it's
what you
not.
observe and what you see and manipulate. Okay, fine. What you can see and manipulate. And I'm saying, I actually observe a different version of reality that I can both see and
No.
manipulate. But
You
there
can
is a-
manipulate gravity like
no,
that.
no, we're not talking about gravity. We're talking
That's
about
what I'm
how we're talking about the theoretical frameworks of both of our worldviews.
Yeah, your
So-
worldview.
No. But
You believe
can
in
I-
objects
can I get-
accelerating
Can I get
that?
this?
Sure,
Can I
sure,
get
sure.
the subjective
Sure.
point out because I think it's so important.
Sure.
So I say I'm moving this.
Sure.
Just for I do see it move. I will acknowledge that I'm not a reality denier.
Sure.
But it is also likely that I can say, wait, no, this isn't moving. The whole world is moving around this. Why is that not valid? Because in my subjective experience, I'm seeing this ball move and I'm saying, wait, this ball is the only stationary thing. The whole world is moving around this ball and we are shaking. That, as you would define it, would be real. That would be a subjective experience. I am saying that there's a disconnect between what you and I view as real. Therefore, there must be an objective reality that is beyond our that is beyond our immediate
Our
experience
vision,
of reality.
yeah.
Right. So,
Beyond our vision, yeah.
how do we arrive to this objective? You say that it's from experiencing, touching, and manipulating objects. I'm saying it's from understanding the underlying principles and theories and truths of objects.
That's the only way to do that is by playing and manipulating the objective.
Absolutely.
It's also,
Yeah,
it's also by checking with others.
Yeah.
Right?
Anybody can
Wait,
recreate this.
You're arguing that the Earth is flat.
Not
That
flat, level.
Level?
Level. Yeah, the Earth is not flat, and I'm gonna tell you why. Over 95% of mainstream flat earthers. Over,
This is
just real
important.
quick,
You gotta expose logic flaws.
because I don't want people to pigeonhole me to flat earthers because I'm not a flat earther. Over 95% of mainstream flat earthers believe in downward acceleration as well because they claim the Earth is motionless, and that's literally the false dichotomy. Flat Earth versus globe Earth is no different because they both believe in this downward acceleration. So I'm not a flat earther. Flat earthers are dumb as fuck and stubborn as fuck. So
Okay.
just want to put that out there.
Okay. But you also claim to believe in objective reality.
Well, yeah, I accept reality.
You accept reality.
I accept reality.
But you deny things that are.
I
objective.
deny theories that contradict my reality.
But he just described to you a theory of gravitational waves. That was going to be my point. I said, well, you can see and manipulate objects with technical instruments, with more sophisticated instruments than our eyes and hands. So how can you deny reality when we are actually experiencing, envisioning, and manipulating reality with very technical and precise tools? Does that not constitute reality to you?
What about
Well,
the only way-
I would say you're just believing all of these tests that they're doing.
Well, no, but you can
'Cause you can't
observe-
recreate them.
You can observe these
What
tests.
about your phone?
So yeah, I'm glad you brought it up.
Like radio waves, things like
No,
that. You
so
can't
my
see,
phone.
observe,
Did you know that everybody's cell phone, everybody's smartphone has an accelerometer built in? That's why you're able to turn the force grid because it detects a force, a vertical force, right? So when you download an acceleration app and you accelerate this phone, it registers 1G obviously here on Earth, But when you accelerate it, it goes to 2, 3 Gs, 4 Gs, depending on how hard you accelerate. It registers that force in any orientation, right? When I put that accelerometer into free fall, it goes from 1 G to 0.
I think his point was more
so
so that
it shows a deceleration.
No.
How is that not a
Wait,
deceleration?
Don't get into this. I think his point was more so that like your phone is you look at it and you're like, this is a black box. How the fuck does my phone work? You cannot see the inner computation of your phone. You know, calculate a list of data to create a certain output. You cannot physically see that or manipulate it without these tools. So if you were to deny reality at the level at which you cannot actually see and manipulate it physically, then how can you explain things like your phone? How can you explain things like lights turning on?
I can get into the specifics of a phone and study them and actually do it myself. Whereas I can't talk about gravity and recreate gravity. That's just, nobody can do that. Not even the.
That's what people do.
I was gonna say.
Yeah, I would say you just believe that.
No, but you're saying you just believe that. There's a
No, I
contradiction.
accept it because I can use it and it works.
And
obviously,
you
we
just
were-
pointed out an
wait,
experiment.
what
They're different.
Okay.
You believe objects accelerate down with no physical measurement of that.
There is.
The
He just provided
the same thing you're saying about your phone is what I'm saying about
Precisely.
like the theories that I use for gravity, right, versus yours. Even if we disagree, right, there's no difference in the way we experience that gravity, right?
Yeah, I guess I would say. Well, we observe things appear to fall down, and yeah, you can interpret that as acceleration, and I'm saying it's deceleration. How do we prove it's one or the other? I guess that's my point.
Whether or not we agree on the fundamental properties of gravity doesn't matter, right? It's
Well,
like
that's the
our
whole
days-
point of this
No,
subject.
hold on.
But yeah, sure.
It's like it doesn't matter. It doesn't impact our day-to-day life, right? Gravity will still affect us in the same ways. However, I think the ultimate goal is A, to understand, as you said, fundamental properties and actually understand how things work, and B, in that describe as many things as possible, right? So one question I asked at the very beginning, you haven't answered, right? With your version of gravity, right? Explain the curvature of light.
I don't need to explain. That has nothing to do with when talking about acceleration and free fall.
But light curves.
I would say you just believe that.
Under
That's
the
something you
influence
believe.
of gravity.
Tell them how you observe that. Tell them the experiment you just mentioned earlier.
There's another. So Einstein explained that through general relativity, and he predicted with that. And 100 years later, after he predicted, he was dead. He said at a certain time, right, we'd be able to observe light curving around Mercury, right? And scientists were able to actually observe that the light was traveling. Light travels in a straight path, right? That's one of the properties of light. Yet it was curving around Mercury. So how else would it do that? Unless it was following the straight path of a bend in space-time.
Right. Honestly, him claiming to see light curving around Jupiter, what is it, Mercury? Yeah, I don't see the correlation from that to physically measuring a downwards acceleration.
Well, here's what his point is. I think that he's trying to make the argument that you actually do observe these things. Under your parameters of reality, you can observe these experiments. If you have technical enough equipment, you can measure light bending around Mercury. So under your version of reality, where you say, I need to be able to see and manipulate it, people are already doing that. So how can you deny it? And you say you deny it because, I'm not seeing it, they're just telling me what to believe. So if I were to give you, let's run a hypothetical. Right. If I were to give you these exact same instruments that these scientists have access to, and the exact same data, and the exact government funding they have access to, and you were to conduct your own experiments, and you saw light curving around Mercury, would you believe in our theory of gravity? How would you?
First of all, if I seen light curving around Mercury, I wouldn't jump to that objects accelerate down in field. I would just say that's a phenomenon that if it was there, which I don't think it is, you guys just believe it. But if it was there, I don't think it proves anything about the Earth we walk on, in my opinion.
But if
I'm being honest.
Okay. Let's say you ran more experiments. Let's say that you had.
Let's talk about basic principles real quick.
I think this. I don't think.
I mean, it's not going to, but I have a very important point to make. Let's say you had access to all of the science.
Before you go, I just want to make a.
Thank you.
You did very well, man. Good job.
Right. You're talking about basic principles of our reality, right? Would you agree that this is a basic principle, that this will always displace in the direction I accelerate? Yes or no? Is that a basic principle of our reality? Because if you say no, I would say you're just a reality denier.
A basic principle
of our reality.
With that exact apparatus on
we could
Earth.
change it. We could use a cargo van with a helium balloon. We could change the medium. We could change the objects inside. My point is, when you accelerate from being at rest, the matter will always...
I would deny that is not a constant, no.
So you would deny that matter...
The gravitational field is strong enough, such as in a black hole, that light can't...
So now we're going to imagination land to explain your...
We've captured pictures of black holes, actually. and we can measure them
Alright.
and see them with telescopes.
I think we're friends. Nobody's ever going to reach an agreement because we have different ways of.
So you
informing
deny
our
that
beliefs.
accelerometer exists on Earth. You're denying that.
No,
I didn't
no.
say on Earth.
They're-
I said that's not a fundamental property.
How is it not?
Of it's not objective.
How is this not objective?
It's
It always does
here
it.
in that container.
Yeah,
like,
and which means if I release this, because we're still here on Earth, it should be affected
Can I
by
make
it,
a
but it's
point?
not.
Can I make a point? I think that your worldview is really dangerous because because you're limiting yourself and your understanding.
I would
of
say
the
you
world.
guys are doing the exact
No,
same
well,
thing you're
let me-
telling
here,
me right
here,
now.
I'm saying I think your worldview is really dangerous because you're encouraging people to limit their understanding of the world to what they can only experience.
You're doing that, and you're replacing theories with practicality. You're doing that, and you're replacing theories
we would
with
regress
practical.
scientifically millennia. And I think that's a really shitty way to look at the world.
I would
because,
say
because in our
that's just an appeal to authority. What you're
No,
doing.
it's not an appeal to
Yeah.
authority. at
Well,
all.
so many people did it before me, so I don't have to do it myself. That's just an appeal to authority.
It's an appeal to the progression of humanity, as in all the things
Appeal
we
to
have.
authority,
So,
I mean.
so let me get my point out. All
Sure.
the things we have today that are life-saving, that make our quality of life so much better, such as light, medicine, electricity, gas.
I don't deny none of those things.
All of these inventions, all of these things that just make our life exponentially better and have
I
pulled
agree.
humans through the throes of shitty living, right? All these things
Sure.
have arisen from scientists who wanted to observe phenomena in their real, objective reality. And in doing so, they needed to observe things that they couldn't necessarily tangibly feel. Your worldview necessitates a world without any of these phenomena, without any of these inventions, because I guarantee you that if Newton was alive today, he would look at Albert Einstein's findings and he would say, "Son of a bitch, you guys have beautiful instruments that I did not have access to in the 16th century. Props, and I believe your view, and I accept it."
Every piece of technology, I agree. It comes from understanding principles. You understand principles. This happens because this happens, and that's how we advance technologies. Is by understanding basic principles, and we build on those principles.
Yes.
The globe Earth starts from a false premise. That's the point.
yeah.
Just because the globe Earth is a lie and downward acceleration is a lie, that doesn't mean every technology is a lie. I agree with technology.
Okay.
Yeah.
My last point before I go.
Yeah, sure.
I think I'm just as likely to change my mind as you are. But my last point
Sure.
before I go is that I don't believe that your theory of gravity is aimed at explaining A, the fundamentals, or B, as many different principles as possible. Because I've asked you to explain how light
Light. I'm
creates-
gonna say that had nothing to do with.
explain the atomic clock and time dilation experiments we did.
What is
with-
time? Let me ask you. What's time?
What's time?
Yeah. What's time?
Okay, that's an extremely.
I can tell you what time is.
Okay, tell me what time is.
It's a concept based on the motion of the sun.
It's based on the motion of the sun.
Yeah, it's a concept. Time is not a real thing.
Time is not real.
Yeah, it's a concept.
Okay, then we get into pretty.
That's what I'm saying.
Like, abstract. you
The
get
fact
into
that
pretty
Einstein.
advanced principles.
Well, that's just.
You
That's
don't
the
have
reality.
to do that for this
But
argument.
you're a reality observer. If you experience this car go from there to there over in progression, you actually as a human experience time. That's what aging is. If you're denying time, you are a reality denier.
I'm not
So you
denying
yourself
time.
say.
I'm not saying. I'm just saying that it's a concept that we created as humans.
So it's a real thing. But if it's a concept, it's a real thing.
It's a concept based on motion. Yeah.
It's not based on time. Okay, time is.
If we didn't
not
have the sun
independent-
or the moon,
no,
how
I
would
agree.
we tell time?
Time.
Oh, we would age. Our cells would grow. Our time is completely independent of the sun and moon. Time is
Time
universal.
is independent of sun and moon, but it's tied into motion. And if you want to get into that, that's Einstein's theory of relativity.
Okay.
Motion, time, light, right? Okay. I think you would benefit greatly from picking up Einstein's theory of relativity, right? Special and general theory of relativity.
Right.
Understanding what he believed, his thought experiments, taking some math classes, and understanding the math, I think that would benefit you greatly.
All right, sure. I would say that's your opinion, and yeah. All right.
All right.
I mean, anything
I
else?
think that's it. That's
Yeah.
all I got.
All right. Appreciate it, man. I appreciate the chat, man.
Yeah.
I appreciate that.
too.
Okay. Okay. You guys wanna? Here, you guys could take my flyer. I go to other
I'll take
universities.
the flyer.
Yeah.
I'll take the
Here, I'll
flyer.
give you one too. This is here. I'll give all of you one.
Alrighty.
Here, I'll give you one more. Last one.
All right, give it to Brandon.
Yeah. All right, man. Take care.
Have a good one.
All right, you too.